Hi, Tim Two Wheels here, and on this how-to/KLR maintenance series video, we're going to be changing the primary drive chain along with the front and rear sprockets on our KLR650. So stick around, we'll get started right after this. Maintaining the primary drive system, which on a KLR650 is a chain and sprockets, is a common maintenance issue for any chain drive bike. So at this point, my chain that I have on the bike, which is a standard O-ring steel chain, is starting to show some signs of wear, is starting to have some kinks in it, and I'll show you some examples once we get the chain off the bike of what to look for and know when it's time to change. The chain that I have on there now is a standard steel O-ring chain. And the one that I'm going with here, I'm going to be using a primary drive gold chain. So it's still in the package here. So this is the gold chain, which just means it has a plating on it to help prevent corrosion and rust. Helps retard that longer than a standard steel chain would. Also, this is an X-ring chain. So the differences between O-ring, X-ring, and standard chain that does not have seals in it is the fact that you have these rings, these seals that look like this, that go in between the outer plates and the inner plates. So the seals help keep lubricant in and also helps keep outside debris, dirt, grind, sand, and water out of the chain mechanism. Now the difference between an O-ring and an X-ring is just the shape, the cross-section of the ring itself. What's on my bike now is a standard O-ring chain. The O-rings look just like you would think a standard round O-ring. The X-ring, however, if you look at a close-up cross-section, it looks like this. The X-ring, it just looks like an X on a cross-section. So the theory behind an X-ring is that it has smaller areas of contact, therefore less wear of the ring against the chain itself. And in most cases, it will also provide a double layer, a double barrier because of those X protrusions against the mechanism to keep grease in and debris out. In addition to the chain, it's also recommended that you always replace your sprockets, because the sprockets will tend to wear. So it's just a good rule of thumb that changing your chain, change your sprockets along with it to get a good fit. While I'm at it, I'm also going to be putting a new front sprocket on. Now this front sprocket is a 16 tooth. It's also a primary drive sprocket. And you can tell it has the number 16 stamped on it right here. So the stock front sprocket is a 15 tooth on a KLR. Now, this is probably one of the most discussed topics among KLR owners is 15 versus 16 tooth on the front end. Now in this video, I'm just going to show you how to change the sprockets and the chain, okay? But I am going to have a follow-up video that's going to focus on the differences, the performance differences between 15 and 16 tooth sprockets. So be sure and look for that video. All right, in addition, while I'm changing the front sprockets, I'm going to do one other thing to my bike to help improve it. It is to add this Eagle Mike Prevailing torque nut for this particular model bike. Now, what is a Prevailing torque nut, you may ask? Well, but the torque nut is designed, if you've ever looked at your KLR in the stock configuration, you have the counter shaft where the front sprocket is mounted, and then you also have a large washer that goes on in front of that sprocket and then the nut. That washer is typically folded over on one edge against the flat surface of the nut to kind of act as a locking mechanism to prevent that nut from backing off. It works well, but when you go to change that nut or that front sprocket, it's kind of a pain to have to bend that washer back up, and then when you're done, you got to hammer it back over, down, and eventually that washer gets kind of all bent out of shape, literally, and then it's just kind of a pain. So what happens is a Prevailing torque nut has the ability to stay locked in place, and also you can take that nut off and put it back on many, many times without wearing it out. The Prevailing torque nut from Eagle Mike just allows for those front sprocket changes much easier without having to deal with bending over that washer. All right, so that's what we have, and that's what we're going to be doing, and that's why. So let's get out to the shop and get started on changing that chain and sprocket. So to get started here on the chain and sprocket removal, first of all, I have the bike up on a jack stand here, up on a motorcycle stand, so I can move it around. The first thing that we want to do is to remove the covers. The front sprocket cover here is removed by 3 10mm bolts. There's one at the top and 2 in the bottom down here. And there's the last one. So now we can work this off. It should come off nice and easy. And that's all there is to it. Good time to clean this crud out of here too if you want. Okay, now that we have the front sprocket cover off of the bike, you can see the nut and the sprocket back here and the chain where it goes around. This is your main drive sprocket or your front drive sprocket. The way in order to remove this nut, there's a few little tricks. You know, first of all, if you rotate it around, you'll see at some point, like here, the washer is bent over. Now, this nut has been changed before with the previous owner. Actually, this washer should be bent over one of the flats of the nut as a locking mechanism. In some cases, you'll see where it's bent over twice, one on opposite sides. So what we want to do is to take, ideally, you'll want to take a punch like I have here and drive it back, and then just take a hammer and flatten that back out. Now, I have seen people use screwdrivers or whatever they have available. You know, from a safety perspective, you're not supposed to hammer and use a screwdriver like a chisel. I know a lot of people do, but it could shatter. So wear some eye protection, and then we just want to hammer this back. It's a pretty soft washer, so it doesn't take a lot. So what I'm going to do is basically just tap it back out of the way in a few spots here, and just get that washer somewhat flat there. Now for the next step, this is a 27mm nut, so you want to use a 27mm socket to fit that. Now obviously with the bike in neutral, especially since I have it up off the ground, when we try to turn this, it is going to turn. Many of the videos you'll see people using a long breaker bar or a really long ratchet like this one, put on here, get on the bike, put their foot on the brake, have it in gear, and struggle to break that loose. The ideal way, if you have one, is to use an impact wrench, which I happen to have one, and that's the method that I'm going to use. I realize not everyone will have an impact wrench. It doesn't matter whether it's electric or air, pneumatic, like I have here, but as you'll see, it makes it a lot easier. Now, I have a clamp on the rear brake, and I'll show you a picture here. Makes it nice and easy to hold it because I have the bike up off the ground. So what we're going to do is just get this started on here, and that easy, it's off. As you'll see, it's a lot easier to do it this way than, again, trying to use a ratchet or a breaker bar because this nut is torqued on here. So now we have our standard OEM nut off of here. So let's go ahead and get the washer. And as you'll see, the washer has been bent up a little bit because of previous uses. I'm going to go ahead and flatten this out a little bit better. Then next we want to go ahead and loosen our chain and get the chain off the sprocket, and then remove this front sprocket here. Now as you try to move, you can see you can slide the front sprocket so far, but because of the tension on the chain, it's not going to come off of there. So our very next step is we want to loosen the tension on the rear wheel, the nut on the other side, then slide that forward in order to get the chain off of here. And we can even go ahead and break the chain and take that off. We're going to have to do that anyway, so I'll show you how that's done. Okay, so when you're ready to take your chain off, you'll need to check. Depends on what type of chain you have and what type of link, master link. Some chains will have a master link, which makes it easy to pop off and remove the chain. My particular chain is one of the old original O-rings, and I've gone all the way around it, looked at every link, and of course you want to do that to make sure, but I already knew I do not have a master link on this particular chain. So what I'm going to do is everything is riveted in place. So I'm going to use a device to break this chain. I'm kind of a fan of some of the Motion Pro stuff, and what I'm going to use is this device here. It's called a PBR, and it stands for you can press, break, or rivet, is what the PBR stands for. So it's kind of a multi-purpose chain tool. It is kind of pricey, but I use this for many different purposes, and it does work on 520, 525, and 530 chains, all with this one tool. So the first thing that we're going to do is to break our chain. So take the cover off. This is a new little unit, but comes with instructions, and then the tool itself is inside here. So I'll show you how to set this tool up to do what I'm going to do. That's kind of extra as part of this video, but just in case you have one of these or you're interested in one of these, you'll get to see how they work. I'm not saying you have to buy one of these. There's many tools out there that will do the job. If you have a master link, you don't really need a tool. You can do that by hand with just simple like pliers, needle nose pliers, and maybe a small punch to get this out of here. But I can't on this one, so I'm going to show you how this tool works. So one of the things we're going to do is get this out. Has a handle that you screw in here that gives you a little extra leverage so when it's together. And if I can get it to where the light hits this just right, you'll see that on this little block here, you have a P, a B, and an R. And then you want to align that up. You'll notice that on the base of the unit, the tool itself, you'll see where it has a press, a break, and rivet. Let's back this punch out of here, the press. So the block comes out, and then you can flip it to align it. So if you're going to use it as a press, you would align the P up. If you're on a rivet, you put it like that, which we're not really going to be using the rivet feature. And then the R lines up with the rivet on the tool. But in this particular case, the first thing we're going to do is to break. So the way that I had it set up originally is with the B lined up with the break on the device, and then that's going to allow us to break the chain. Okay, so there are detailed instructions that come with this device that you can use to show you how to use the tool. So if you buy one of these, you'll have really good instructions with photographs, color photos, to show you how this works. All right, so I'm repositioned here. I'm going to break the chain down here where it's a little easier to get to. So I have my tool set up in the brake configuration. So we want to turn the top nut here and extract this press, the pin, or the extractor pin, I believe they refer to it, about 3 or 4 millimeters in. And then what we'll do is we'll tighten the main press shaft here down, and then get it lined up with our whatever pin. So we just pick a pin that we want to remove. It doesn't really matter which one. Backing it out. So you'll notice there's an indentation here, or a hole here, and then of course our shaft, we want to get the pin lined up in there. So we have it on the back side. So now I'll tighten this front side down, and you just get it to where it securely rests, or it's got some pressure. That is a 17 millimeter here on the front. So we want to just tighten it up where it's snug, doesn't have to be super tight. And then what we're going to do is use a 14 millimeter to tighten the pin down against that. And then we just continue to tighten. And what it'll do is it'll just drive that pin right out of the chain. Now it's going to take some pressure because these pins that are riveted, But if you just keep working it, it's going to be tight. It will eventually get easier as the pin presses through. And that's why this handle is on the PBR tool. It's already starting to get easier here. And there we go. I can feel it getting easier to the point where I can screw it by hand now. So what we want to do is to back out that pin. And there is the pin that came out of our chain. As you can see, it pressed that right out. Okay, let's lay that down. So now we have broken our chain, so we can actually go ahead and pull that apart, just like so. And I don't know if you saw that, but here's a little O-ring that is in there. That acts as a seal, and that fell out. So now let's go ahead and we can turn and work that chain right off of our sprockets. And off, keep doing it, it's coming off the back one as well. So there we go. We now have our old and very stiff chain. There's one way for sure you can tell how it needs to be changed is you notice these kinks in here. If your chain doesn't freely move, then it's not doing its job. This one is not too bad, but it has definitely seen better days, which is why I'm replacing it. Okay, so now that we have our chain removed, it's going to be a piece of cake. This front sprocket will just slide straight off. All right, so now our old sprocket is really not in too bad a shape. You'll notice it was starting to, against something where you can see more definition, you'll see they were starting to kind of slope in that direction. The teeth. It might be hard to see, but it's there. When we compare it to our new sprocket that we're going to use, it does not have the divots leaning forward. It's more uniform. And this one is not bad. This one definitely has some mileage left in it, but it was starting to get that scallop, the teeth kind of leaning that way. So anyway, we're going to go ahead and replace this. Now, I am using, as we talked about earlier in the video, I am putting a 16-tooth front sprocket on, and this is the stock 15-tooth front sprocket. So to install the 16-tooth front sprocket, you'll notice the two sides are different. The side with the thicker lug on it and the 16, and of course this is a primary drive, so it's got their logo stamped in here. That's going to go to the outside. Doesn't matter how you put it on there, so let's just get that on there. So if we take our Prevailing torque nut out of the box, or out of the package, not the box, you'll notice it does look different. So in my left hand here is the OEM factory nut, and then here is the shiny one is the Eagle Mike or Eagle Manufacturing Prevailing torque nut. So to put this back on, I have put my washer, actually I used a vise to clamp it and to get it as flatter than it was. It's still not perfect, but it doesn't have to be. So what you can do is just put this back on, and the washer has these teeth in it. So and what the teeth are designed for is to fit just up on the edge of this sprocket here. On the shaft. When the sprocket is on, there's just a little bit of the teeth of the shaft that are still exposed. So we take our washer, put that up on there, and that's to really act as a locking mechanism so that when it's on there, it does not spin, which is why you're able to use it to bend over and lock the nut into place. I had one spot that the teeth didn't want to go up in, so I just used a hammer lightly to tap it up onto the teeth. Next is the Prevailing torque nut. So we just simply spin that on. So one key note, the factory nut that came off was a 27 millimeter, and the Eagle mic is a 30, so it's slightly bigger. So just make a note of that. Now I've got the bike in gear, and I'm just going to use a ratchet to snug this up. You could use the torque wrench, or I'm sorry, the impact wrench again, but this is torqued as stated to 72 foot-pounds, and I could have used the impact wrench lightly, but I'm using the gears now, the transmission. I've got it in first to hold the shaft from turning so that I can snug this up. And I just want to do this by hand. I don't want to run the risk of causing any damage to my internal gears. It may not, but I'm just not going to take that chance. So I'm going to snug this up until I can get the chain on and the back sprocket and use the brake, and then we will use our torque wrench to get this Prevailing torque nut to its 72 foot-pounds of torque. Okay, so over here on the right side of the bike, since we used the technique of breaking the chain to get it off the bike, I didn't have to loosen the rear axle and slide the rear wheel forward in order to get the chain off, as we could have done. So now that it's time to replace the rear sprocket, I am going to go ahead and pull the rear wheel off to replace that sprocket. So to do that, there is a Carter key in here that we need to bend around and pull this key out that's securing this castle nut. So let's go ahead and get that bent around so that we can remove that castle nut. So it may be difficult to see, but there's just the pin is a split pin, and so we get the ends bent down, get them as straight as we can, and then we can pull this out. Pretty basic stuff, but I like to show the details on my videos. So let's remove that. And so now this castle nut is a 27 millimeter. So let's just break that loose. Not that hard to do. Now before we take the nut all the way off, I like to back the nut out and then just use it to tap to start that axle loose. And as we see, it just breaks the axle loose so that we can push it on out. That is much better than battering on the end of the axle bolt itself. You don't have to hit it very hard, but that will help break that loose. Okay, so now that we have the nut loose here, you can see the axle is loose. I can wiggle it around and slide it out. But before we take this off completely and remove the axle to remove the wheel, the one thing that does have to come off first is this rear brake caliper. The rear brake caliper is held on by two 12 millimeter bolts. We'll need to remove those, but it is a lot easier. This bottom one can be a little difficult to get to depending on how your rear brake line is mounted. So I'm going to go ahead and remove this brake line guide here, and that is an 8 millimeter bolt here. So let's go ahead and get this out of here. And so that is held on with that one bolt, and it can just hang on the line. It's not going to hurt anything, so just leave that there. Just set the bolt aside, make sure that you have that. Next is to remove the two 12 millimeter bolts here and here to take the caliper off. So as we take this last one out, be careful not to let that fall. It should hold on there okay. But then the brake caliper will lift off of the pad, or of the disc. And this is also a good time to check the thickness of your brake pad since you got the caliper off. Anytime you remove your brake calipers, it's a good time just to double check the life left in your brake pads. All right, so at this point, we can go ahead and remove the rear wheel. So let's go ahead and take that castle nut off. There's a washer here, and then the slider, or the adjusting mechanism. These bolts adjust and press against this to move and slide your axle on both sides to align your rear wheel and to adjust your chain tension. And again, I'm just pulling the axle from the other side until that is off. Then set the rear wheel down on the ground. And just in case you've never seen it, there's your rear axle. So let's just set that aside. A good time to check it for any sort of scoring or unusual wear. This one's okay. And at this point, we can go ahead and just pull the rear wheel out of the bike. Again, hanging onto this slider. You'll see there's some grooves on it. Just don't want it to fall. There's a lug on the inside of the rear fork, or the swing arm. Now we'll go and take the tire over to the side and we'll change this sprocket. Okay, so with the rear wheel off, I have it laying on a pad here on the floor of the garage. You do want to be careful and not put any unnecessary pressure on that brake rotor. It's not touching, there's not going to be a lot of pressure on it. I know some people say that you need to have a holder or whatever, or put it up on the blocks. Now if you're changing the tire, I agree with that because you're putting a lot of pressure on that rim when you're changing the tire. But in this case, just be gentle. All I'm going to be doing is removing these bolts and replacing this rear sprocket. Again, it's not going to be any pressure, anything that's going to damage that rotor. So just wanted to point that out to you. So using again, a 12 millimeter socket or wrench, you need to go around and break loose each of these nuts that are holding this sprocket on. Now you notice I'm doing it in an opposite pattern, it's just a habit. Whenever I'm tightening or loosening bolts like this, I tend to want to go. So as I take these off, I'm going to use what I consider to be one of the handiest inventions for a shop. I'm going to put these in my magnetic tray here to keep from losing them. Okay, at this point, we should just be able to lift our sprocket right off of the hub, just like that, and remove it. All right, so now, for those of you who don't know it, there's also, you can lift this hub out, and this is what's known as your cush drive. Okay, it's a rubber bumper. Mine is still within tolerances, but that is what gives the cush. It's not just a hard connection between the sprocket and the hub or the wheel. But if you ever have to replace it, this is how you do it. You just pull it out, and then these rubber inserts come out. You put your new cush drive in, and that's all there is to it. Not changing that today, but just thought I would show it to you while I'm here. So this is our new primary drive. Again, this is a stock 43 tooth sprocket. So it's going to be the exact same size as our old one. No change in the gearing. We're only going up one tooth on our front. So this part is pretty simple, straightforward. Just put the sprocket on as the old one was and put the nuts back on there. Now, as we put the nuts back on, we will tighten them in a cross pattern. And we will also torque back to 32 Newton meters or 24 foot-pounds. Again, I just snug them up by hand again with the ratchet, and then we'll come back and torque them. I'm not putting a lot of pressure. I'm just bringing them down until they basically hit the sprocket. All right, so back here I have my torque wrench set to the 24 foot-pounds, and I'm just going to go back around and hit these until they torque. And that's the star pattern. So we can go check, and now each of them are torqued. Make sure that we didn't miss any. Just double checking. There we go. So they're all torqued and ready, the wheel's ready to go back on the bike. Okay, so with the new sprocket on, we've got the rear wheel back on the bike. I'm leaving the axle nut loose because we do need to back this off to put the new chain on and then readjust the tension. But I have reattached the rear brake caliper, and just a note of interest is that these caliper bolts are torqued to 18 foot-pounds. They're already torqued. The brake line guide is back on. So now what we need to do is put our chain on, and then we can adjust our tension on the rear wheel, and we'll be done with this job. All right, so as part of the tensioning the chain, we do need to, these adjuster bolts here, as I mentioned earlier, this bolt presses out and presses against this plate, which slides your rear wheel, provides tension outward. You can use these hash marks to figure out where you're at. But what we want to do is to loosen this jam nut that's back here against the swing arm. I've already loosened that. That is a 12 millimeter. So we want to spin that out, and then we want to turn the bolt in. And it might be a little stiff, just depending on the condition that your bike's in, but you can get an end wrench in here. It's about the only way that you can get to this and adjust it. So what we're going to do is to turn this in essentially to this first mark here. You shouldn't have to go in any further than that. You can, depending on how many links are in your chain. We're going to take it back to there, and what that'll do is it'll allow our wheel to slide all the way to that point. Now I need to do the same thing on the other side. Once we do that, we'll slide our wheel in and snug this nut up just to hold it in place, and then we'll put our chain on. So where we are now, we have our new sprocket installed on the front and the rear. The rear wheel is back on the bike. We've adjusted our chain tensioners all the way in, and the wheel is up and just snugged at this point. So we have not yet torqued our front nut, and we have not secured our rear axle and adjusted the chain tension, but what we have done is taken our nice new shiny chain out of the package, and we're getting ready to install this. So as we've already talked about, I did go up one tooth on the front gear, but this is still the stock. It's a 520. This is an X-ring chain, and it is 106 links in length. That is the stock size for a KLR650 of this year. So let's go ahead and put it on. One thing different I'm going to do is I'm not going to rivet a link back in here. I am going to use a master link to put on, and the reason I'm doing that is that would make it easier to repair the chain or to remove the chain on the trail or on the road if I have to, by having a master link. So let's go ahead and feed this guy back in here. So maybe an easier way to do this, but I'm just feeding it up on that rear sprocket, pulling it forward. Then I'm going to wrap it around my front sprocket like so. Put that in neutral would help. And then turn the sprocket around, wrapping the chain. Keeping a little tension on it so that it keeps the kinks worked out of it. And then bringing it back around here. And we get it started back on the rear sprocket, and we'll wrap it back around. And as you'll see, it worked out perfectly. All right, so as we're getting ready to put our master link on, again, we'll be putting it right here in this, but just wanted to show you up close what the master link looks like. So for those of you who aren't aware, master link consists of one of the an outside plate. There's inside plates and outside plates. So it consists of an outside plate with the two pins in it. That'll come through from the back side. We have, in this case, this is an X-ring chain. So we have our 4 X-rings that are part of it, and they will go on the pins where the plates and the pins meet. So the outside plate goes on, and then this clip, this black clip, will go on the outside to secure. It fits in the grooves here on this, these pins to secure the plates and the pins. And then this is a pack of lubricant that will go on. You want to squeeze the lubricant wherever the seal plate is on the pins and the X-rings in this case. If it's an O-ring chain, it works the same way. It's just a cross-section of the rings are X versus an O. So then we're going to take our back side of the plate and we're going to slide our X-rings in place, just like that. And then we want to coat them. And I hope the focus is okay there, kind of working up close here. Then we want to squeeze some of the lubricant on here and just be sure and coat it really well because you want to make sure it's sealed. The rest of the links are sealed at the factory, so it's our job as the installer to make sure that we get plenty of lubricant on these rings where we're going to put those in place. Now the reason, again, for the purpose for the rings is to help keep lubricant in and debris out. So there. So we've got those rings covered. Might be a little more than we need, but hey, better too much than not enough, right? So from the back side, I'm just going to install these pins into the link. And now you'll see they're sticking through the front side. So we want to do the same thing on here, is to install our rings. And you can put lubricant on first, you can put it on after. The main thing is just make sure that you have plenty on here. All right. What's the excess here with the rag? So now the outside plate is going to go on. And you will not be able to get the clip on, or you should not be able to. You'll need to actually compress it. So I have my PBR tool set up in the press configuration. So in this case, our little anvil goes up here. Align the P with the press on the tool body itself. And what we're going to do is this will allow us to press the plate. The indentions in here are designed so that it will press that plate onto the link. I'm just going to take up the slack here and make sure that you're in so that it's not trying to press on the pins, it's only pressing on the plate itself. Now this procedure does not take a lot of pressure, not like at all like when we are riveting or breaking the chain. We just want to snug it up against there so that what it's doing is it's compressing those X-rings so that we can get the clip on. And you can kind of see by looking in here how far you have to go to expose the recess on those pins. And we've got that. I'm just going to let it set for a minute. You can see that's clearly exposed. And then we'll start backing this off. It should be enough pressure so that the plates will stay compressed while you take this tool off and are able to get your clip on. Now, the clip on a master link, it is very important which way you put this on. As you can see, it is open on one end so that it can snap in place. You want this closed in to travel with the direction of the chain. So your bike is going to rotate. So we want to put our clip on, in this case, in this direction. The reason for that is if you put it on backwards, and you can put it on backwards, it's more likely if you were to hit a stick or hit anything, it'll knock that clip off. And then your master link could eventually work its way out, and then your chain comes off the bike, and then you got serious problems. So that's why you put the master link on in that direction. So we will just put it up here. Now you don't have to drive it on all the way from the top. You can put it on like this, and there's an opening here to get that front pin in, and then the back one. And at this point, you can typically take a pair of needle nose pliers, putting your bottom on the inside of that top plate, and then here, just applying pressure, and like that, it snaps into place. Now that master link is completely installed at this point. So now, see, the way the chain is going to travel, that master link, even if it gets hit, it's not going to knock it off the bike. It's going to just keep it secured. And then I'll carry a spare master link in my toolkit on the bike, so if I ever do lose it, or if I break a chain, I can repair it on the trail using master links. Okay, so to talk about chain tension here, we have the new chain on and I have it relatively tight. As you can see, there's not a lot of play in it at this point. So now to adjust your chain tension properly, you're supposed to find the midway between the two centers of the two sprockets. So I've marked on my swing arm here right where that is. I just simply measured with the bike elevated and the wheel off the ground. As you can see, the chain and free spool. Okay, so for chain play, you should have somewhere between 35 and 45 millimeters of play. So I have a couple of markings here. This is center line. I adjust the tape accordingly to where the center of the chain is. And then I have 25 millimeters marked here, and then that's 40 on the outside. So I typically want to have it somewhere a little more than the 25 and somewhere around the 40 millimeters in play. You can bring it in a little tighter to where it falls right in between these two marks. You can come up with your own way of measuring this, but this is how I do it. So here with the square up against there, and the camera angle is gonna, I can't get my camera any lower, but you can see the play I don't have near enough. I only have maybe 20-25 millimeters of play. So that means I need to loosen my chain just a little bit more. So I'll do that and then remeasure. So it does not take much. I made like half a turn. And let's remeasure here again. And in the center, I can come up to the center of that and almost to the center down. So maybe just a tad bit more play. I have noticed that since I'm a heavier rider, I do, when I sit on the bike, especially with a full load, it really puts tension on the chain. So I run my chain just slightly on the looser end of that scale so that it's not so tight. So here we try it again. We're up at the top and we're down at the bottom here. So that is good chain tension right there. It's within my range here and here. So that's going to be good. So the next step is on the chain tensioning nuts here. I want to make sure that I have my wheel aligned properly. So I will adjust on both sides to make sure that I'm the same distance from these marks, and then that'll assure that my wheel alignment is proper, and not only that, the sprocket alignment with the chain. You'll notice if you're not in alignment, you'll get a lot of wear on one side or the other of your sprocket. And so this will ensure that it's in alignment. Once I have that readjusted, I will then recheck my chain tension again to make sure I'm still good. And then we'll tighten everything down, torque it up, put the covers back on, and that's all there is to it. Okay, we have everything back together. The rear axle has been reinstalled and the rear axle nut has been torqued to spec, which is 72 foot-pounds. The rear castle nut, the pin is back installed. Our chain tension is set properly and wheel alignment is set. The last thing that we need to do now is to torque this new counter, the Prevailing torque nut to 72 foot-pounds per Eagle Mike's specifications, and then put the front cover back on. So with our torque wrench still set to 72 foot-pounds, which is what I used on the rear axle, let's apply some pressure, and there. It is now torqued properly. All right, so everything's back together. Have all the covers back on, front covers back on and secure. Rear, everything's torqued down, so we're good to go at this point.